So my dear students, today we are going to discuss an important topic of chemistry. So this topic is not only important for chemistry, it is also important for physics as well. So here comes the topic, that is thermodynamics. Thermodynamics. So the word thermodynamics tells everything about it. Thermodynamics is composed of two words, that is thermo and dynamics. Thermo, we all know that thermo means heat. So here thermo means heat, and heat we means heat energy, that is heat energy or thermal energy, heat energy. And dynamics we mean motion. Dynamics we mean motion, and motion is the synonym of work. So this branch, that is thermodynamics, so it is a branch of science that deals with the interconversion of heat energy into work or work into heat. So we can define thermodynamics as it is a branch of science. It is a branch of science that deals with interconversion of heat energy to work or work to heat. There is an interesting fact regarding the origin of this thermodynamics, regarding the birth of this thermodynamics from our experience. So from our experience we all know that work can be converted into heat. That work can be easily converted into heat. How? So in ancient times, people know that by rubbing two stones or by rubbing two sticks. So by rubbing two stones or two sticks, we can generate heat. So rubbing is nothing but it is work. We can generate heat or we can create fire. We can generate heat. So rubbing is nothing. It is just work, and this work is getting converted into heat. So we all know from our ancient times, and ancient people also know from their experience that work can be easily converted into heat. So work can be easily converted into heat. We all know that. By convention we all know that. Converted into heat. But scientists want to figure out if heat can be converted into work. That is a great challenge for the scientists, to convert heat into work. We all know that if a reaction goes forward, then it may go backward. So scientists ponder upon the fact that if heat can be converted into work. So this idea gave a rise to the birth of this new branch of science that is called as thermodynamics. So if heat can be converted into work. So from this gave this idea, that is this idea of converting heat into work gave rise to the branch of thermodynamics. To the branch of thermodynamics. But this creation of thermodynamics is not a matter of 1 or 2 days. Rather, we have covered a long journey. We have developed few laws regarding this conversion of heat into work or work into heat. So by the development of thermodynamics, by using thermodynamics, now we are using thermodynamics in heat engines. So heat engines are nothing. They are they are created just by the branch of thermodynamics. So heat engines, steam engines, steam engines, power plants, all these arises just because of thermodynamics. And of course, the 2-stroke, the 4-stroke, internal combustion engine, IC engines arises by the application of thermodynamics. Application of thermodynamics. So we apply a few laws of thermodynamics to generate these types of engines or these types of useful things. We'll deal all these types of laws that are of importance in thermodynamics. But first of all, we have to understand the terminology related to thermodynamics. So there are few terms that we have to deal in thermodynamics. So terminology of thermodynamics is very important. Thermodynamics. And the first and most important term in thermodynamics is system. So system. So system is the part of the universe or the part of space that is under observation. So system is part of universe or space. As we know all that space or universe are same. So part of universe or space that is under observation or that is under study. That is under observation or study. It may be anything. It may be a cup of tea. It may be a satellite. It may be a steam engine. It may be a heat engine. It may be a whole power plant. So the part of universe that is under study. So it may be a cup of tea, a cool drink, a cool drink bottle, that is under observation, or a satellite that is under observation, or engine of a vehicle, of vehicle, or a piston, etc., etc. Any part in space, any part in universe that is under focus, that is under study, called will be called as system. And besides system, the part of universe that is left is called as surrounding. That is surrounding. Surrounding. So surrounding is part of universe except system. Part of universe. Universe except system. So these two things are very important. They are very important because there is a strong interaction between system and surrounding. So universe is composed of system as well as surrounding. So suppose this part, this is whole universe, and I am preparing a tea. I am preparing a tea in a tea pan. So this water inside the tea pan will be called as system. So this tea pan with water will be called as system because my whole focus will be on this tea pan. My whole focus will be on the volume, will be on temperature and pressure of the tea. So this tea pan will be considered as the system, while rest part of the universe will be called as surrounding. So tea pan can be called as system because I am mainly focused, or I am mainly worried about the properties of the tea inside the tea pan. So tea pan will be considered as system, and the part of the universe, that is kitchen, home, and the atmosphere around this tea pan will be considered as surrounding. So we have system and surrounding, and we are very much concerned about the properties of system and surrounding because they interact with each other. They interact with each other. System interacts with surrounding and surrounding interacts with each other. For example, if the day is too cold, then it will be very difficult to prepare a tea. While on the other hand, if the day is hot, then tea can be prepared easily. So if the day is very cool, then it will be very difficult for me to lit a fire. On the other hand, it will be very easy for me to lit a fire in sunny or in summers. Similarly, if the pressure is very high, so the boiling point of the water will be high, and similarly, if the pressure is too low, then the boiling point will also be low. So the surrounding affects the properties of system. Surrounding affects the properties of system. So system plus surrounding is called as universe. So system plus surrounding. So we have to deal with the property of both, but my main focus is system. But I have to be apprised of the properties of surrounding as well, because for instance, if you are going to lit a fire to prepare a tea, then that area should be calm. Then there should not be too airy. There should not be wind flowing in that area, because it will be difficult for me to lit a fire in windy place. So the surrounding plays a very important role to decide the property of a system. And similarly, system also affects surrounding. If the tea is very hot, it is going to release more heat, and if tea is very cold, it is going to absorb more heat. So system and surrounding affects each other. That's why we have to deal with the properties of both system as well as surrounding. So system plus surrounding is called as universe. System as surrounding is called as universe. So these are the two basic definitions. Now on the type of system, that is the part of the space that is under focus, the part of the space that is under study. Systems can be of three types. Now we all know that there is an interaction between system and surrounding, and this interaction can be of three types. Means system and surrounding mainly interact through two manners. They interact in terms of energy. energy. So system and surrounding interact with each other in terms of energy and in terms of mass. So on the basis of the type of interaction between system and surrounding, on the basis of energy and mass, system can be of three types. So types of systems. Types of systems. So on the basis of the exchange of energy and mass between system and surrounding. System and surrounding. System can be of three parts. But this categorization of system in three parts just based on the interaction of system and surrounding in terms of energy and mass. So I'm going to categorize system into three parts. That is system. So we have three types of system. That is part of universe that is under observation can be of three types. So I'm going to draw a line of that. So here comes the line. Okay. And one more line. Hold on. One more line. So we are going to categorize it into three parts. So one is open system. So I must say that types of system. Three types of system. One is open system. Another is closed system. Another is closed system. And third one is isolated system. It is isolated system. So isolated system. So just on the exchange of energy and mass between system and surrounding. System can be of three types: open system, closed system, and isolated system. And these can be defined by their names as well. For example, open system is a open category system. So open system is a system that can exchange. So system that can exchange both, that is heat as well as mass. Both heat means energy, both heat, energy, and mass with the surrounding. So there may be exchange of heat and mass between system and surrounding. System may absorb heat from the surrounding, or it may release heat to the surrounding. Similarly, it may receive mass from the surrounding, or it may release mass from the surrounding to the surrounding. So open system are just kind of open. They are open in nature. For example, cup in open or tea in open cup. For example, tea in open cup. So if this is, sorry, I have to be. So suppose this is tea in open cup, or you can say water in open cup or hot water in open cup. So what will happen? This open cup is hot since the surrounding is cool and the water is hot inside it, so it will radiate energy. And it will evaporate mass, or it will evaporate mass. So with the evaporation, its mass decreases, and with the radiation, its energy will also increases. So it is giving out heat energy and it is giving out mass to the surrounding. Reverse of this can also happen. For example, if you have ice inside a beaker, open beaker, so vapors, so ice will absorb heat. Similarly, the vapors from the surrounding will condense, and the mass of the water inside the beaker will increase. So there will be condensation, and the water from the surrounding will gets deposited, or will start to deposit inside the beaker, and heat inside the beaker will increases, or the system. Now this is our system. So system is, we are mainly focusing about the properties of ice here, or the cold water inside the beaker. So system is absorbing heat, system is also absorbing mass from the surrounding. So this is how system and surrounding exchange heat and mass in open system. There may be removal of mass and energy, there may be removal of both, there may be absorption of mass and energy between system and surrounding, or there may be removal of one, or absorption of one, or there may interact in any way. So this was how open system got its name. So now we have a system called as closed system. So closed system. So from its name, you can determine that closed system are closed in nature, means they are enclosed in a boundary. So closed systems are closed in nature. Since they are closed, so they cannot exchange mass. So such system do not exchange mass with the surrounding. But exchange of energies takes place. Exchange of energy takes place. Energy between system and surrounding. System and surrounding takes place. How? Just to have an example. For example, if I have a closed container having ice inside it, so what will happen? If surrounding is hot, surrounding is hot, then ice will absorb heat energy from the surrounding and melt into water, but the mass of ice, or the mass of matter inside the box, will remain same. There will be only change in the temperature, or there may be change in the state of that matter inside the ice, but the mass remains intact. Even if you open the container, even if this container is intact or it is enclosed for 1,000 years, then also the mass will remain same. Although there will be exchange of energy, but there will not be exchange of mass. So closed systems are closed in nature. So a cup in a closed container, or a tea in a closed container, or a cool drink inside a closed container is a kind of closed system. So closed systems are closed in nature and open systems are open in nature. Now we have a system called as isolated system. So isolated system is a kind of system that is totally isolated. So the system is totally isolated from its surrounding. So there will not be systems. So I must draw a line here to create a partition. Very well, partition is created. Okay, so isolated system. So system that is totally isolated from its surrounding. Totally isolated. Totally isolated from its surrounding. From its surrounding means so must rise down in short. From its surrounding. Means system is unable to exchange heat and mass with the surrounding. So there will not be any. There will not be any exchange. Any exchange of heat or energy and mass between system and surrounding. System and surrounding. Remember, isolated system is not a real system. In day-to-day life, we do not experience such kind of system. We have not generated a type of isolated system so far. So it is an ideal system. So it is an ideal system. Ideal system. So it is an ideal system. Remember, it is not a real system. We cannot have an isolated system, purely isolated system. So it is not a real system. It is not a real system. We haven't developed such kind of system, that is isolated system. And because we haven't developed a container that can prohibit the exchange of energy. There will always be exchange of energy. You cannot stop energy from being exchanged between two things. Even we have exchange of energy between two planets. We have exchange of energy between sun and moon, sun and another planet. Even there is exchange of energy between sun and Pluto. That is too far. So you cannot prohibit the exchange of energy. There will always be exchange of energy. So we cannot have a perfect isolated system. That's why isolated system is a kind of ideal system. We have not a perfect insulated system so far, that is insulated from the energy point of view. Okay, now look at some examples. So open system, I have given example of open system is an open cup. All these open, where then there is open word, or where there the matter or the system, that is the part of the universe that is under observation, is of open category, that is called as open system. So open cup of tea, cup of tea. Similarly, oceans are open, we cannot cover it. Oceans, lakes, ponds, etc. are open because they do exchange energy with their surrounding. Means there is evaporation from the ocean, there is evaporation from the lakes, there is evaporation from the ponds. So with the evaporation, not only mass changes but energy also. There is exchange of mass as well as energy. Now, closed system. So closed system are of closed nature. So there will be closed. So when there will be a closed word, then that will be called as closed system. So closed system. Example: water in a closed bottle. Water in a closed bottle. Got it. Similarly, a closed box having ice. Ice in a closed box. Ice in a closed box. So this is, and isolated system, we cannot means have an isolated system. Although isolated system, if you talk about isolated system, then universe can be considered as a example of isolated system, because in universe we have covered all the things. So universe is isolated system. So isolated system. Main example of isolated system is universe. Because we have covered everything in the universe, so everything will be considered as a system. There will not be any surrounding. Since there will not be any surrounding, so universe will not be able to exchange energy between system and surrounding. So universe, that is the universe considered as whole system. If we are focusing on the universe, then universe becomes our system, and there will not be any distinction between system and surrounding. So there will not be any surrounding. If there will not be any surrounding, so there will not be any exchange of energy and mass between system and surrounding. So universe is a kind of isolated system, remember. Now, if you have understood this content so far, then you will be able to answer few questions. So you will be able to answer few questions. Now we will discuss about the category of, we'll discuss mainly the category of different types of systems. So I'm giving you few examples, and you have to distinguish whether the given example is an open system or a closed system. So here comes. So now categorize the following. Categorize the following objects or matter into open, closed, or isolated system. First is Earth. Come on, think about it. Whether Earth is an open system, isolated system, or a closed system. So the answer will be open system. Earth is an open system. How? because there is exchange of energy. If we take Earth, then whole surrounding, rest of the part of the universe will be called as surrounding. So besides Earth, Moon is a kind of surrounding for Earth. Sun is a comes under surrounding for Earth. Planets, meteors, stars, all will be considered as surrounding for Earth. So Earth can exchange. Earth not only can, but it does exchange. Earth exchange energy from Sun. Earth receives energy from the Sun, and it also radiates energy back to the universe. So there will be exchange of energy in the form of heat. So Earth exchange. So Earth exchange both energy and mass, because we have meteor shower from the universe to the Earth. So the Earth mass gets increased because there is exchange of both energy and mass with the surrounding. So Earth is an example of open system. Now the second one, or you can say any planet, Earth or any planet is a kind of open system, or any object in the extraterrestrial space is a kind of open system, because it is in the interaction of a sun, it is in the interaction of its own satellite if it has. So there will be exchange of energy and mass between two or any two extraterrestrial body. So this kind of open system. Now second is, what about humans? Are humans kind of open system or a closed system? I just told you that anything that is under observation, we do observe humans. We do observe the temperature, pressure, weight, mass of the human beings. That is why humans can be considered as a system. So what kind of system human beings are? Whether they are open system, closed system, or isolated system. Come on, think about it. Your time out. Okay, so humans are also kind of open system. Open system because we do exchange energy with our surrounding. If the temperature outside our body, if the temperature of the atmosphere or the environment outside is too low, then our body radiates heat. If the temperature outside is too high, then our body absorbs heat. So similarly, we can exchange heat energy, we can exchange energy with our surrounding, we can absorb, we can release energy to the surrounding. Similarly, we can exchange mass through ingestion by eating and egestion by removing mass. So humans exchange both heat energy and mass with its surrounding. Or you can say humans or any living being. Any living being is a kind of. Third is universe. Although I have told it to you, universe. What about universe? So universe is a kind of closed system. Universe. So universe is a kind of isolated system. Remember, all isolated systems are closed system. So isolated system. Or you can also say that it is a closed system as well, because all isolated system are example of closed system, but reverse of that is not true. All isolated systems are closed system. but all closed systems are not isolated system. But all closed systems are not isolated system. Okay, for example, universe is an isolated or closed system, but ice inside a closed bottle will be called as closed system but not isolated system. If a closed system is able to prohibit the exchange of energy, if closed system is able to retain its energy and it is not able to exchange energy with its surrounding, then only a closed system will be considered as isolated system. So this statement is true, but it is also true. So that's it for today. So we'll discuss more about it later. That's it for now, because it will be a lengthier lecture. So thank you for being patient. Thank you for listening or understanding the concept. For all your queries, I am open. You can text me, email me on my channel. Thank you.